Hello everyone. Today we're going to talk about a new section of college algebra. We're going to talk about section 3.6, polynomial and rational inequalities. So we have learned before about polynomial equations and how to get the zeros of the polynomial, how to find the multiplicity of each of those zeros. We also learned about the rational, how to get the zeros of rationals, how to find the domain, the range, and how to graph the rational functions. We have learned before about inequality, but we learned about linear inequality. Linear inequality, we learned how to find the zeros and then we graph the linear inequality. Today we're going to learn about something new is non-linear inequality. One of those non-linear inequality is the polynomial and the other one is the rational. I started with the first video talking about the polynomial, and then in the second video I'll talk about the rationals. Okay, I'll start to explain how to find how to solve the polynomial inequalities in 5 steps. So I'm going to write the 5 steps and they are already in your notes, but if you'd like to watch the video so you can have the whole steps in front of you. So, number 1. Rewrite the inequality with the zero on the right. Number 2, solve the equation when equal to 0. So instead of having less than or greater than, I'll set it to 0. Number 3, create a sign chart, and we'll see how to do that. It's like number line, and we put the zeros on the sign chart and we test the signs. So number 4 is testing the signs. Test each interval to determine whether the polynomial is positive or negative, whether and find the last step is use this information to solve the inequality. Okay, so let's look at the 5 steps first real quick. So the first thing is to make everything to the left side and the right side is 0. The second thing is to, when we solve an equation, we have to have an equal. So I'm going to change the sign to equal to 0, and then I solve my equation. After that, I have to list the zeros on a number line, we create a sign chart, and then to test each interval, whether it's in each interval the equation is positive or negative. And we have learned about that before with the rational functions. So let's get an example and see how to solve that. So if I have x squared minus 6x plus 8 less than 0. Okay, so here's my inequality. It's polynomial, second degree, and I need to solve that. So the first step is to rewrite the equation with the 0 on the right. Already the 0 is on the right, so I'll skip step 1. Step 2, we exchange the sign less than to equal. So number step 2 here, I'll make this x squared minus 6x plus 8 equals 0. Clear so far? The third step is to find the zeros. So we need to solve this equation. So I'm going to solve it, x factor this x and x. And here is 8 positive and 6 negative, so I have 4 and 2, or negative 4 and negative 2. So now I have two zeros, comes from here. I have here x equal 4 and x equal 2. So I got the two zeros. So now I'm going to go to step 3 to create the chart. Perhaps this is step 2, step 2. And here's step 3. I create the chart and I plug the two zeros, 2 and 4, and at each of these I have a 0. So now I'm going to plug a number that is less than 2 and I test in this interval between negative infinity and 2 whether the sign here is a positive or negative. So we choose a number that is less than 2. The easiest one is 1. The easiest number is 1. So I test x is 1. It's easier to test in the factored one here than plugging 1 here and 6 times 1. So it's going to be more complicated if you use this step. So I would plug the 1 in the factored polynomial here. That would be easier in testing that. So x minus 4 times x minus 2. So I have, since x is 1, I have 1 minus 4 times 1 minus 2. So I know that 1 minus 4 is a negative, and 1 minus 2 is also negative, because 1 minus 2 is negative 1, 1 minus 4 is negative 3. So negative times negative is positive. So therefore, in this interval, I have positive. Okay, so far? Now, I need to check a number between 2 and 4. So, perhaps I check 3. Okay? And I check, so 3 minus 4 times 3 minus 2. 3 minus 4 is negative, because this is negative 1. And 3 minus 2 is 1, which is positive. So negative times positive is negative. So therefore, I have in the second interval between 2 and 4 is negative. The third interval, I have something, I pick something greater than 4, so I would say x equal 5. So I have 5 minus 4 times 5 minus 2. 5 minus 4 is a positive, because it's 1. 5 minus 3 minus 2 is 3, also positive, and positive times positive is positive. So now I have positive here. Okay, but let's look at this one here. It tells me that this must be less than 0. So this inequality is true when the statement here is less than 0. So now, in which interval x is, the inequality is negative? So only in between 2 and 4. Therefore, my solution is the interval 2 and 4. So only here I have negative numbers. And I can't add 2 and 4 or 4 because I have just less, not less than or equal. Does it make sense? Alright, let's support this idea by another example. Alright, so I have another example. here, I have 3x cubed minus 4x squared is greater than or equal 75x minus 100. Okay, the first step here is to get everything to the left. So I'm going to add or subtract 75 and add 100 to here. So I have 3x cubed minus 4x squared. And then I subtract 75, so I have negative 75x. And then I add 100. So when I subtract 75 and add 100, I must have this is greater than or equal 0. Okay? Now I'm done with the first step. The second step is to set this equation, this inequality to 0. And in other words, is to convert the inequality to equation. So 3x cubed minus 4x squared minus 75x plus 100 equals 0. Alright, now this is a very big equation, but if you look at the pattern here, it looks like we can work in this equation by grouping. So if you group this, I have a common factor, here's I have a common factor, and I can have a common factor that makes it works. If it doesn't work, we can use any other technique, but for this one, grouping is working. Okay, so I'm going to factor grouping the 3x squared, 3x cubed minus 4x squared, and then plus negative 75x plus 100, which again equals 0. Alright, so I see that I have a common factor here, x squared. I have x squared, so I have left here 3x, and here is minus 4. Okay, now I have negative 75 and 100, so I can have negative 25 as a common factor, and negative 75 divided by negative 25 is 3x, and plus, or here is minus, because 100 divided by negative 25 is negative 4. I see the pattern here. So I'm going to factor 3x minus 4, and I have left here x squared minus 25. But again, I can factor this. This is the difference between two squares. So I can have x minus 5 times x plus 5 equals 0. So how many zeros do I have here? 3. 1, 2, and 3. And we're going to solve each one to 0. So I have here 3x minus 4 equals 0. That means 3x is 4. And I get x equals 4 over 3. For this one, I have x minus 5 equals 0. So x is 5. And the last one, x plus 5 equals 0. So x is negative 5. Now, I'm going to do the similar one to this one. Similar number line. And we test the intervals. Okay. So I have a number line here, and I have how many zeros here? I have 3. I start with a negative 1, so I have negative 5, and this is 0. And I have 4/3, which is 1 1/3. So here, 4/3, and I have 0 at that point. And I have 5, and I have 0 and 5. Okay? So now I have to test in these 4 intervals. So I start by getting a number that is less than negative 5. So say negative 6. And I'm going to test Well, this one, because this is the easiest one here, the factored one. So I have 3 times negative 6 minus 4, and then negative 6 minus 5 times negative 6 plus 5. Okay, so I will test here. I have negative 3 times negative 6 is negative 18, negative 4 is negative 24, negative 6, negative 5 is negative 11, negative. Negative 6 plus 5 is negative as well, is a negative 1. So the answer here is negative times negative is positive, times negative is negative. Therefore, this area is negative. Okay, I need to take something between negative 5 and 4/3. So the best number here is 0. So x is 0. So I have 3 times 0 minus 4, 0 minus 5, and 0 plus 5. So here is 0, I have negative, and here is negative again, and here is positive. Negative times negative is positive, times positive is positive. So I got positive here. Now between 4/3, which is 1 1/3, and 5, I think the easiest number is 2, so I'll check x is 2. So if x is 2, then I have 3 times 2 minus 4, 3 minus 5, 2 minus 5, and then 2 plus 5. 3 times 2 is 6 minus 4 is positive. 6 minus 4 is 2, so that would be positive. 2 minus 5 is negative, and 2 plus 5 is 7 is positive. Positive times negative is negative, times positive is negative. So I have here negative. Last thing, I get x equal 6. So I get x equals 6. And I have 3 times 6 minus 4, 6 minus 5, 6 plus 5. So I have 18 minus 4 is positive. 6 minus 5 is positive, is 1. And then 6 plus 5 is positive as well. So positive times positive is positive. And I have this here positive. Now, I'm done with everything here, and I have the testing line, or the chart here. So now I need to figure out what is my statement. So my statement is greater than or equal 0. So where is the inequality as positive or equal? So I have here, and I have here. So I'm going to erase that here. So the solution here would be negative 5 and 4/3. Okay? But what parentheses should I add? Parentheses or bracket here? Here it says equal, so I need to include the zeros. So 0 is at negative 5, the inequality equals 0, so I have to include negative 5. And again, at 4/3 I have 0, so I have to include it, which is going to be brackets. But I have another interval here, is 5 and infinity, and 5 also as a bracket. And union. So this is the solution of the second problem. All right. I'm going to give you another problem. This problem has multiple steps, so we're going to go through it, and it has different idea. Okay, I have 11 x to the 4th plus 28 x squared less than x to the fifth plus 322 x cubed. And I'm given that 2x is 2 is 0 of this inequality. Okay, so first of all, I need to make one side 0. So I'm going to remove all of these to the other side. And when I remove it, I change the sign. So I have negative x to the fifth minus, let's make it in order. So I'm going to get this first, because this is the fifth one, and then I add this one. And this the third one, I move it with negative, so negative 32x cubed. Then here, I keep it as it is. And then less than 0. Because I removed it, and while I'm moving the stuff from the right to the left, I changed the sign and put them in order. Okay, actually I don't like this negative, so I'm gonna multiply by -1 to make the first one positive. So I'm gonna change the sign of each term. In addition, I'm gonna change this sign. So x to the fifth minus 11x to the fourth plus 32x cubed minus 28x squared, and now it's going to be greater than 0. Okay? Alright, so what I see here is that I can take x squared as a factor. Each one of those has x squared. So I'm going to factor x squared here. But before I factor that, I need to set the equation in step 2 and make the inequality equation. So I'm going to set this x to the fifth minus 11x to the fourth plus 32x cubed minus 28x squared equals 0. Alright, I'm going to factor x squared. So I have x cubed minus 11x squared plus 32x minus 28 equals 0. Now, I know that I have one 0 here, is x squared, which is 0, x is 0, with multiplicity, as we learned about that before, 2. So for this the fifth degree polynomial here, I must have 5 zeros, but those are 2 out of them. So I must have extra 3. So I have to get 3 extra zeros from that polynomial. Alright, but I am given that I have 2 already. So I have 2 and I want to figure out the other 2. So I have also x is 2. But how can I do that? So I'm going to use synthetic division to divide this by x minus 2 or divide by the 2. So I'm going to set the synthetic division. And here I'm dividing by 2, which is the 0. And here's x cubed, I'm writing the coefficient 1, negative 11, 32, and negative 28. Using the synthetic division, you get the 1 down, multiply by 2, and add negative 9. Negative 9 multiplied by 2 is negative 18. 32 minus 18 is 14. 14 times 2 is 28. Minus 28 plus 8 is 0. And I should expect that the remainder is 0 because I'm given that x is 2 as a factor, and based on what we have learned before. So now I have x squared minus 9x plus 14. Okay? And now I need to factor that to get the other 2 zeros. So far I have x is 0 with multiplicity 2, so I have 0 twice, and I have x is 2, so I have 3. And now it's quadratic equation, so I should get also 2 zeros. Okay, let's factor that. It's easy to factor it. Equals 0. I have x, and 14 is 7. Negative 7 times negative 2 gives me negative 9. So here is negative 2 and negative 7. So I get here x is 2 and x is 7. Now I have 2. This 2 is different than this 2. So now I have x is 2 with multiplicity also 2. And the fifth one is x equals 7. So let's write the equation in a factored way. So I have x squared times squared, because I have 2 here. And then I have here x minus 2. But guess what? I have this twice. Here is x minus 2. It gives me 2. And I have another 1, 2. So that must be with multiplicity 2. So I have to write squared. Okay? And then I have x minus 7. And with how many multiplicity? Just 1. So if I count, I have x with multiplicity 2, with 2 zeros, and x minus 2 with 2, and x minus 7, 1. So 1, 2, 3 is 2 is 5. Okay, so this is my polynomial right now. So the second step is to draw the number line and put the zeros. So I have 0, 2, and 7. And I have zeros here at this point. Remember that we are looking at the positive. Alright, so I'm going to test this here. So I'm going to pick any number, negative number, less than 0. So x equals negative 1. So if x is negative 1, it's negative 1 squared. And here negative 1, negative 2 is negative 1, negative 2. And x minus 7, so they're going to be negative 1, negative 7. Here is squared. Remember that any negative number, when it's squared, any negative number must be positive. So I don't have to worry about that. This is positive and positive. So I worry about this one. So negative 1, negative 7 is negative 8, which is negative. So positive times negative is negative. So again, you don't have to worry about any squared because they must be positive. So you don't have to compute them. Okay, so I got here negative. From 0 to 2, I get x is 1. And again, I don't worry about that. That must be positive, positive. So here's 1 squared, 1 minus 2 squared, and 1 minus 7. So here is positive, positive, and negative. So again, I got negative here. So here the area between 0 and 2 is negative. Now how about 2 and 7? Let's get 3. So I have 3 squared, 3 minus 2 squared, and 3 minus 7. Again, positive and positive because this is squared. So positive, positive, and negative. 3 minus 7 is negative 4, so my answer is negative. So negative here too. Have you noticed something? Have you noticed that this is negative and negative and negative? There's no negative, positive, because if you remember what we talked about before, about the multiplicity, you touch the line. So again here, with multiplicity made this negative and again this negative, and this negative because of the multiplicity at 0 and the multiplicity at 2. Okay, so the last 0, I'm going to pick 8, so x equals 8. So I have 8 squared, and I have 8 minus 2 squared, and 8 minus 7. So here again, positive, positive, and 8 minus 7 is 1 positive, so I have the answer is positive. So here is positive. Now back to my problem. I want the equality where the interval where the equality is positive. So that must be this one. So my answer, 7 is not included, so my answer would be 7 and infinity. I hope that everything is clear here. And if you have any question, don't hesitate to email me, or we can talk about that later. Thank you, and see you in the next video. Thank you.